Usually when you search for something on a search engine or in the search box on a website, the text you entered will be compared against all the available content looking for exact matches. For example, if your query was best Italian restaurants, it would find results closely matching this phrase exactly or with minor variations such as typographical errors. But this approach might not always get you the results you want, since it doesn't always take into account an understanding of contextual nuances, synonyms, related phrases, or user intentions beyond the exact words used in that query. But there is a way to do a search that finds information that has the same meaning as what you typed in that search box. And it uses what are called embeddings. And that's what we're going to talk about in this video. Welcome back to the Ollama course. This is a free course available here on this YouTube channel that will teach you everything you need to know about how to use Ollama to run artificial intelligence models locally on your laptop, on your computer, or even on an instance that you own up in the cloud. So far in this course, we've mostly covered how to use the basic functionality of Ollama and how to find models, as well as the fact that size doesn't always matter. We started to talk about Retrieval Augmented Generation, and a core part of that technique is to take advantage of embeddings to find the most relevant information for a query. Now, let's go into more detail on how embeddings work. So when we talked about embeddings in the RAG video, we learned that they are typically stored in a vector database. In some cases, the creation of the embedding is initiated by the vector store. In other cases, you'll need to start the action yourself. And then sometimes the database itself knows how to do the comparisons, and sometimes you have to do that yourself too. In all cases, the actual embedding is created by the embedding model. Now, you can create an embedding with any model, but the results are always going to be better and usually faster when you use a model designed for embeddings. When you create the embedding, you get an array of floating point numbers. Here are the first 10 for an embedding made with the nomic-embed-text model for the phrase embedding is fun. Nomic-embed-text uses 768 dimensions, so that array would have 768 floating point numbers. An embedding for a short phrase of 2 or 3 words will have an embedding that is 768 numbers long. And so will a document with 8,000 words. But that's for nomic-embed-text. Other embedding models may have more dimensions and so would have a longer array. Once you have a collection of many of these arrays, usually called vectors, you can do some neat things. One that is useful for our needs is called cosine similarity. This will find the distance between two vectors, but what is really important with that is that running the calculation is very fast on most modern CPUs. And the distance can also be thought of as how similar the two vectors are. An important thing to note here is that the vectors must all be the same length. Vectors of different lengths cannot be compared. So if you change the embedding model used at some point, you'll have to re-embed anything you created an embedding for in the past. As I mentioned in the RAG video, you prepare the vector database by creating embeddings for each of the chunks of the source text. And then for a given query, you create an embedding of the query and find the vectors that are most similar. Then get the source text for that embedding and feed that to the model. So how do you actually create the embedding? Well, let's take a look at using the Ollama API. You can find the API documentation in the GitHub repo. Go to github.com/ollama/ollama and then navigate to docs and then API. This documents the endpoints for the RESTful API. There are actually 3 endpoints available that can do embeddings, but only one that should be used in pretty much all cases. First, there is /API/embeddings. This was the original embeddings endpoint and will be deprecated at some point in the future. Then there is /v1/embeddings. This is the endpoint for embeddings that is compatible with the OpenAI API. As with the rest of the OpenAI compatible API, you shouldn't really use it unless you absolutely have to have compatibility with that API. It'll always be behind the native API, and there are some things that Ollama can do that are just not possible with the OpenAI compatible API. The endpoint that you want to use going forward is /API/embed. This takes an object with 2 required parameters, the model to use and the text to embed. The text can either be a single string or an array of strings. This means that if you have 50 chunks of text to embed, you can either iterate through each of the chunks and create the embedding, or you can pass them all at once in one request. Now, you might think that doing them all at once would have a pretty big impact on the performance, but the difference is actually very minimal. We'll see this in an example coming up, and the results may surprise you. To use this endpoint, you can use any language that you like to call the API. Or if you prefer to use Python or JavaScript or TypeScript, then you can use the corresponding SDKs. You can find the repositories under github.com/Ollama. If you're using TypeScript or JavaScript, then the code looks like this to generate an embedding. With Python, it looks like this. As you can see, the two are pretty similar. Although they are written by different folks in the Ollama team, the two of them sit a few feet from each other in the office and talk every day. Let's take a look at a simple example I put together to compare embedding models. I wrote this using the JavaScript SDK and used TypeScript with Dino. So if you get the code and have Dino installed, then run Dino task start, and it will run the program. This creates embeddings from a document about the Incuba-LM project, which is a smaller LLM that was designed for lesser used African languages such as Swahili and Zulu. The reason I chose this doc was that it came out in the last few days, and there's no way that most models will know anything about it. The first thing you'll see it do is try to answer 3 questions. I asked the same 3 questions over and over again in this example using different embedding models. Next, it pulls the HTML page from archive and then ensures that you have all the models pulled that the example uses. Now, it starts working with the nomic-embed-text embedding model. First, it creates the embeddings using the batch process, where the embed endpoint is given an array of strings that each are a chunk of the original document. Creating all the embeddings took 1.57 seconds. Then it does the embedding separately for each chunk. And we see that it's a few milliseconds faster. Next, we answer the 3 questions. We'll see the results for all of them in a little bit. Then it does the same process for mxbai-embed-large, all-minilm, snowflake-arctic-embed, bge-m3, bge-large, and finally for Llama 3.1. Llama 3.1 and bge-m3 are definitely the slowest, and their performance may surprise you. So now let's take a look at the answers to the questions. First, we look at what is Incuba Instruct, which is a dataset. The answer that relies just on the model is just as we would expect. There is no answer. But nomic-embed-text does a pretty good job. In fact, they all do great, though I think bge-m3 has the most relevant info. The answer that used the embeddings created by Llama 3.1 is completely useless. For the question, what is Incuba-LM, we see similar results, though bge-large and mxbai-embed-large seem to perform best. Then again, maybe you would prefer more to-the-point answer, in which case bge-large and mxbai-embed-large are among the worst. And the Llama 3.1 answer wasn't as bad as it was before. Finally, we have the question, how many parameters does Tiny Llama have? In this case, I think a short and direct answer is probably best. Most of them did pretty well, though Llama 3.1 was more than useless once again. Below each answer is a line of scores. In the code, I build a prompt using the top 10 embeddings, but I also search for the top 20 just to be able to list the scores. I think it's kind of interesting to see how relevant each of the embeddings was according to the chosen model. If you want to try out the program yourself, you can find it in the repo. Go to github.com/technoevangelist/video projects, then find 2024, 09, 03 embedding comparisons, and everything's in main.ts. This is an interesting example that starts to look at embeddings, but there are a lot of variables that come into play with them. You can play around with the size of the chunks and whether that size is based on characters or words, paragraphs, or sections. You can choose to have some overlap between each chunk. You can use different similarity algorithms. You can select more or less chunks. And there are more variables too. One of the aspects that may be frustrating here is that there often isn't just one right answer, or even one best answer. And actually, if you ask the model the question and provide it the selected chunks, the model may answer better or worse each time you ask. And we played around with a model for the embeddings, but you could also change the model to ask the question to. So if you get started building something out with embeddings, just know that you're going to have to experiment a lot or just select the variables somewhat at random and move on. At least now you know. And that brings us to the end of another video in the Ollama course. I hope you are finding these videos useful and that they are helping you get better with Ollama. Be sure to subscribe to the channel to find out about new videos as they come out. Thanks so much for being here. Goodbye.